Welcome everybody. Today we will be discussing the next few AI trends in 2025 and how they will influence our lives in the business sector. So there are a couple of interesting trends that I would like to show you, but we will also discuss failed trends and also we will hear a couple of predictions of what awaits us in 2026. So let's dive in. Trend number one, Agentic AI. What does it mean? What does it mean, Agentic AI? When we talk to ChatGPT, it's very cool. It can talk to us. It can make jokes about penguins, but it cannot do stuff on its own. When you think about the vision of order me some flying tickets to some destination, that's the goal of Agentic AI. Now, the idea is that the agent would be able to do stuff, interact with the world. So really do stuff for you. And for this to happen, it needs to also get information from the environment. So it should be able to interact. And what makes it really Agentic AI is its ability to make decisions. Interestingly, the term agentic comes from the sociology, where the idea is that someone has the right to act on its own accord. And by now, you've probably seen the classical use cases for agentic AI. A classical example would be research. Why this deep research? And everybody has a deep research function. The reason behind it is because the AI has to fetch some information, decide based on it what are the next steps, what extra information to fetch, and then go and do it and interact with the environment to get more information. Some other examples you've seen is probably code generation, and not that one where you just get your unit test generated, but code where you tell it, copy me the apple.com website, and then it can go to Apple, it can download stuff, it can analyze it, generate multiple files, save them to disk, and iteratively do this process. So the point of Agentic AI is actually be able to decide on stuff. What actually does it mean? Why is it such a trend? The real reason behind it is because now it allows you to automate stuff that was not really easy to automate before. That parts where human understanding of stuff was needed. An example would be ticket resolution. Understanding what the customer is writing to us was very hard up until now. Now it's possible to automate it with agentic AI that would do stuff. Here are a couple of examples. Just having a research one is cool, but what can you automate that you previously could not? An example here is automating an outreach. So building an agent that can research all of the conference attendees, all of the conference speakers, then transcribe the talks, identify some quotes, and then craft personalized emails to those speakers is something that you would need a huge amount of people doing up until now. Now you can automate such stuff using agents. And now agents come in a few categories. There are different types of agents. There are agents which are in essence automated function, like send an email or categorize something. That's practically an agent that does one thing. The bigger agents is an attempt to automate an entire job role. For example, OpenAI is considering charging $20,000 a month for a human-level researcher. Microsoft is building such a financial analyst. The idea that the agent would try to mimic an entire job or entire business role that somebody is trying to do. Now, $20,000 a month sounds like a lot. But if you think about it, if it can do what an entire human does in an organization, or even replace an entire organization, then is like $1 million, not too much. The third type of agents that we are seeing is actually software-specific agents. At this point of time, practically every kind of software is trying to build agents into that software. A few examples would be from companies that you probably know, like Datadog, the monitoring system built in an AI agent called Bits that acts like a DevOps copilot. It investigates incidents directly from logs. So it's an AI agent that acts with the environment, gets the logs, makes a decision whether it's to escalate or not to escalate, and even can act directly with Kubernetes to increase memory. Elastic has an log and error monitoring and interpreting agent. McKinsey offers agents to modernize legacy IT. ServiceNow offer a bunch of agents to do change management and proactive network testing and incident categorization. SAP with Julie has an agent to do cash collection agent. So it's an agent that checks who did not pay some invoices and reaches out to them. A Q&A agent, a supply chain agent. Confluence has a couple of built-in agents to create Jira tasks. So these are agents that are not a single function, not a job, but they are very specific to a specific software. And the last type of agent is a so-called your own business-specific agent. What does it mean? At some point, Mark Zuckerberg imagined that every company has its own agent that can connect to other agents of other companies and work with them. It means that you will have an agent, for example, for our product, a disposition system that connects with an agent of a gas station and tells them, hey, a customer is now coming and please charge it. And the gas station agent is an agent that belongs to the gas station. So it's literally communication between agents that belongs to companies. And in fact, something that brings us near to this future, and this is the release of Google's protocol called agent to agent. So the idea behind agent to agent is each company or different agents will be able to communicate with each other. Like, you can think about it like this. Your AI agent in your company can communicate to HubSpot. HubSpot is a CRM system, and your AI agent creates a release blog post like, hey, we had a new release, a new feature. And the HubSpot agent will hear about this and create a landing page to advertise this feature. But the HubSpot AI agent knows how to create landing pages. It doesn't know about your product. So it will communicate back to your agent and ask it about its product to get some description. They wouldn't know how you like your page being created. So the agents will communicate to each other to obtain more information. At some point, you can involve a third agent that researches the internet to compare what is the competition doing, how is actually other landing pages of competitors look like, what's important to put there, and which things you can advertise as an advantage. This agent-to-agent communication is something that probably will come more in the near future, but we'll see already frameworks developing around it. Because agents are a little bit like small programs. They're better when they're small and very specialized and can do one thing quite well. It's like microservices in software development world, or like specialists when you talk about human employees. And then they have to communicate with each other to actually achieve a bigger result. Agents cannot do that all by themselves without working with the tools that we currently have. And agents connect not only to each other, but also to the set of tools. So a HubSpot agent would work with the HubSpot API. Our disposition agent will work with our disposition system. And this is also a trend that is growing and being fortified by protocols such as the MCP, the Model Context Protocol. This allows connecting any kind of API that you currently have to a chat, to an LLM, so it can communicate with it. But that's not the only possible connection to the LLM. A lot of the interfaces that we currently have are still meant for human. Like when you work with a computer, a lot of the thought went into UX, how you operate, how you use a system. And one of the emerging trends for using those interfaces is actually training a computer to work, the LLM to work with any interface of the computer. These are called computer use agents. And now, by now in April 25, practically every big player has some variation of computer use agent. A computer can take screenshots of what on the screen and decide where to click next to achieve any specific outcome. Where does it take us? What will happen when a LLM can act with a lot of computers? What when we connect everything over MCP, when the LLM can call any kind of API? And here comes prediction number one about what will wait us in 2026. And these are AI cockpits. The idea would be that in the future, an employee can only open his ChatGPT or any Copilot or any chat interface and just talk only with it the entire day. It would tell it Bring me all the features from all the tasks that I have from Jira. Write some code into this and this repository. Research that and that. Send that email and the other email. So what we'll probably see is that a lot of the knowledge tasks would be done in one single interface, the AI cockpit. If you only take away one thing from today's entire trend presentation, this is it. AI agents will change how you think about what's possible for your business. And what you should be taking away from this is the following. Think, what can you do with 100 junior employees? Think what you can automate that you could not automate up until now. Can you now personalize some stuff? Do more. Can you generate personalized landing pages? Everything that you could not do until now, think about it in terms of what if you had 100 junior level employees that could do that for you? This is the biggest future and promise of AI agents. This is why the valuation of OpenAI is so huge, because they promise that such AI agents will be able to do a lot of stuff. Now, they're not doing it on a PhD level yet, and the tools are also still evolving, but this is where we are going. This is the trend. So what's still evolving? We still see ecosystems around agents evolving in the sense of testing, how to test ecosystems, how to deploy them, how to monetize them. We still need some way to version them. So everything that applied up until now to software still applies to agents. And we see evolving ecosystem around it. We see frameworks growing. We have frameworks from the open source community. We have frameworks from the big providers. So OpenAI has the agent toolkit. Google has an agent development kit. We have LangGraph. We have from Microsoft one. We also see that the cloud is going in that direction. So cloud starts to offer agent hosting. Both Amazon, Google, and Microsoft, Amazon, and Google have some sort of agent engine where you can deploy your own agents. However, it's still a new phase in software development, so there's still a lot of things to figure out. We still see evolving ecosphere, but I predict that we will also this year see a lot of evolving architectural patterns, best practices, security ideas. For example, the first feedback to the MCP is still huge security issues because a malicious person can inject something in a shared protocol across multiple agents. So how to do it correctly, how to best structure it, this is still emerging and the entire industry is learning on the go. Now, we've talked a lot about business agents, but a lot of people don't understand this. In the near future, we will have something like personal agents where you would tell it, hey, as Mark Cuban put it, I have 6 kids coming in the evening. 2 of them are vegan. 1 of them is lactose intolerant and 3 of them are a total mess. I want something to feed them. Just get it. And the AI would be able to figure out what it is and order it by itself. This is coming to the consumer segment. And we already see how it's coming. For example, Windows Recall, which is finally coming out now, already being slowly rolled out, will be constantly monitoring what you are doing to see what's going on with you and learn from this your preferences. ChatGPT released a memory function. Now it remembers everything from all of your chats to learn about you, to know who you are, and to understand what you want, how you think, and what's your interests. So ChatGPT is integrating memory. Windows Recall is a memory. What we will see is this AI learning more and more about you by sitting on your device, monitoring your work, learning from your questions. So if you were thinking that Facebook used to collect a lot of information about you, welcome to the AI age. Now, the near future and why all the major companies are working on the following is the next prediction. Prediction number 2. We will see AI glasses, which will be always on. There is nothing more convenient than always having a camera on your face and AI always knowing what you're looking at, what you're monitoring, what is interesting for you. And this AI will be able to learn your preferences and do stuff for you better. So what we will see is a personalized AI in the consumer side with most likely AI glasses, which will be always on. Now, what will run all of this? How will this all work? And this brings us to the next trend. Trend number 2, very large models as well as very small models. What does it mean? It means that over time, if we look at this graph, the compute power that goes into training of every model just increases over time, almost 2x. It means that new models are trained with more resources and they become smarter and smarter again. In fact, the compute power used to train models doubles twice a year. So every 5.7 months, models become or get twice as much compute power invested in them. If we look at this graph, we see, for example, this top right corner is a Grok. It used 4.6 at the power of 26 flops of compute power to train. That's huge. It's a number with 26 zeros. An average MacBook can manage only 12 zeros of processing flops, is floating point operations per second. So these are multiple orders of magnitude more processing power that goes into this. If you think about it, the training that goes into compute is increasing almost 4.x per year. So it means it's doubling every 5.8 months. The cost of training is also increasing almost 2.6 times a year, which means it's doubling every 9 months. Rumors have it that training the Grok model was more than $130 million. That's as much money as poured into training these models. The training data that goes into it is also doubling every 2.3 years. The question is, how soon will we run out of data? And no, we did not run out of data yet. The internet is actually quite big, and the current projections are that we will run out of data by 2028. Until then, I'm sure humanity will generate even more data. But also the GPUs themselves improve a lot. So every new GPU is stronger than the previous one, and they also double every 2 years. And the algorithmic improvements, so coming up with new ways to improve stuff to achieve the same result, they also halve the compute needed every 8 months. So new algorithms improve on previous algorithms every 8 months. Models will just get bigger and bigger, but at the same time, they will get smaller and smaller. Because if you want to run them on your phone or on your glasses, that's why you need small models. And practically every big player is trying to invent small models as well. The Meta has a Llama 4 Scout model with just 17 billion parameters. Microsoft has a Phi 4 with 14 billion parameters. Google released a Google Gamma. Now, how do you use those? Here's an example from Wiener Linien, or the transportation company in Vienna. They use these small models for translation right in the driver's cockpit of a bus or a tram. A lot of those drivers do not speak fluently German. Turns out German is a complicated language, and sometimes instructions can come from a central place or some computer, and they're all set in German. But the driver can choose which language he wants to hear the recommendations, like, hey, there's a traffic problem, drive around it. He can choose a different language to hear those, and small language models like this run directly inside the trams or the trains or the buses and help the driver work with the language that is most comfortable for him. Other users also from Wiener Linien, for example, is collecting and fixing sensor data. So a lot of IoT devices generate a lot of sensor data. Sometimes for different reasons it gets messed up, from radio interference, from lost connection and so on. And this is a different use case for small models. But mostly it's needed for the future of those devices that we will probably all be wearing on our faces. One way to make models stronger is to invest more into their compute. So get them smarter and smarter. But a different approach is to have them think longer. And this is trend number 3, inference-time compute. What does it mean? In current machine learning systems, the performance of a system is related to how much compute or how much processing power was spent during the training process. So the better we learn the mathematical statistical patterns while we train the model, the better. However, it's also possible to improve the trained model at the cost of increasing its thinking time during usage. For example, models can be reduced, made smaller, but instead spend more time thinking or reasoning through something called chain of thought. It increases the cost of the operation at runtime, which can be charged later to the consumers, so to us, but reduces the time of training. This can also make the model smaller and make it operate faster. If we look at the trend here, what we will see is that AI is now capable of spending more time thinking about the problem and trying to solve it for longer time. What we see is a graph that shows how long a model could be working on some task. This picture is from a study called Measuring AI Ability to Complete Long Tasks, and AI can now work longer and longer independently. However, there are still limitations. Why is it not infinite? Why we cannot just put a computer to think about it for a week? We still have some technical limitations, such as the context size, the cost, the hallucinations incurred. So if the model hallucinates and goes one direction, it will just keep going in the wrong direction. And this is something that we will need to solve. And on the bright side, the cost of using LLM falls every year tenfold. So if we paid $100 in the past, 1 year later we pay $10. 1 year later it's only $1. You get the idea. Every year the cost of using an LLM gets divided by 10. This affects not only the big models, but also the open source models. The open source models that we currently have are not far behind the closed source. They just about 2 months lagging in terms of how they perform. The question is, what makes some model better than another model, or how the big players compete against each other to make you use their model? And the idea here is most of the models will be more or less the same in terms of how good they are. So if you can do something with ChatGPT, you can also do it with Grok and with Gemini and with any other provider. So the big players are actually trying to compete on everything around it. For example, they all try to offer free access to universities. So students, when they learn to use one tool, would want to come to the workspace and say, yes, we want this specific tool because we are very used to work with it. We already know. And this is done not only by these guys, but also by AutoCAD, or Microsoft used to do that. They would offer free licenses to schools. So kids like me will learn C# when they're in school, and then they will continue programming with Microsoft ecosystem when they grow up and say, no, I only do Microsoft stuff. They also offer us a free tier. Like, why do we get all of these tools for free? One side, because they train and learn from that. On the other side, because that's how we get a vendor. We are accustomed to one vendor and get used to it, and we continue just using them. And here's an interesting take. OpenAI started working with industries, different industries, the automotive, the healthcare, to develop specific rankings and metrics for that specific industry. This is a lot of proprietary knowledge. When one company knows what exactly some industry needs, they can specifically tailor their models to perform even better in those industries. And this is how big companies compete. At current point of time, the levels between all of the models are quite similar, even though we see some differences, like Cloud is still better in writing and creative tasks, and even in programming, and ChatGPT is better in general math. But the real crux comes now again with personalization. When one system knows everything about you and gives you, when you ask a recipe for your favorite tiramisu, and the other system doesn't know anything about you, that will keep you stuck with one of them. Now, which tasks can AI take from us if it can do them forever? In a sense, at some point of time, yes, we'll go tell AI, go think about a cure for cancer and come back, and then AI will go and think about it for 3 weeks and come back with a result. We are not there yet, but in the meantime, AI already can do some coding. And this brings us to the next trend called vibe coding. What is vibe coding? Where is the vibe? So the idea of vibe coding is coding without actually understanding code. It's used in two different ways. In one of them is people who cannot code can now actually create code in a way that they feel like it, but it also reduces a lot the cost of rewriting code. So if you generated some code and it didn't work, it didn't do what you were expecting, you just don't like it enough, Instead of fixing it, debugging it, and changing it, you can completely wipe it out, click a button, and regenerate it again. So these are the two ideas of vibe coding, but specifically it's marketed as a tool for people without coding experience doing coding. Here's an example of some tool, and there's a huge amount of them to do vibe coding, to edit a corner radius. Now, vibe coding is now still split into two categories, low code and no code. By tools like low code, I mean Cursor, Windsurf, GitHub Copilot, Whisperer. These are tools where you can ask a LLM that sits with you in your coding environment to generate some code from you. This is mostly used by developers and it's very helpful, but there's also a different class of vibe coding tools, completely no-code tools. The most famous one is maybe Replit, which closed a 200 million valuation recently, but there are many, many, many more. There's Lovable, Bubble, Software, Zapier interfaces, Flutterflow, Backendless, Glide, Mendix, Syncable. All these names, you just need an AI agent to figure all those out. And interestingly enough, Y Combinator, the famous venture funds startups, says that in its recent cohort, so in the last batch of startups, almost in each one of them, more than 90% of the code is generated by AI. Now, this is interesting to remember that it's still startups in the face of a POC trying to find a market fit. But Gartner assumes that by 2026, around 3/4 of all new applications will be low-code generated applications. Sometimes, and as we all know, low-code has its promise of low barrier of entry. You still need to know what you're doing. You would need to know that what you're changing here is called corner radius. If you don't know that, you will have a hard time explaining the LLM what you want. The bigger problem with vibe coding currently is bad vibes. So vibe coding enjoys all of the big sides of coding. What you see is an example of some guy who is working on his startup. So he posted on Twitter that he did vibe code everything and it looks great. And just a few days later, he says, oh my God, random things are happening, maxed out usage on API keys, people bypassing the subscription and creating random stuff on the database. So vibe coding does not really replace understanding of coding, and it has its own problems. For example, it is very weak in understanding what to edit. If you are working in your editor and you say, oh, please change something, it only in 40% of the cases actually know which file should it change, where should it go, and how to adapt stuff. It is possible that it's easier to throw away something and just let it regenerate, but you still need to know actually, do you expose your API keys? Is your security good enough? And mostly, and not all, software development is not only about the coding part. Here, what can happen? This is a conversation of somebody who just deployed stuff to localhost. For those of you who are not developers, the joke here is when you deploy something to localhost, it's not available to the world. You're the only one who sees it. But the bigger question is, what are the implications of vibe coding? What does it mean? Does it mean now that agencies like software development agencies are not needed anymore because everybody can now do stuff? No, I don't think so. But maybe there will be a new type of service called Vibe Coder as a Service. Why? The real reason behind it is just as drag and drop website builders and no-code tools existed until now, this is just another no-code tool. But does it mean that business people will now stop doing what they're doing and sit down and drag and drop their own websites? Mostly likely not. Companies still want to do the things that they're doing to change the world in the way they want, and they still need somebody who understands all this computer stuff to build it for them. It's not like they're going to stop and sit down and go and use all those low-code tools, even if you can. Now, what else will change is maybe a new industry. So if we vibe coded stuff, You would also want people to vibe check it, verify that the code is good. And also maybe there will be something like vibe security. So maybe people will generate the code, but will come to agencies and ask them to verify and check that this is doing what it's supposed to be and it's secure and good enough. Eventually, maybe that process would be also automatable. But for now, vibe coding in production, we've seen how it works out. What about enterprise software? It can be less strict. It runs inside the organization. Most of the people who use it is a limited amount of people. It can be less strict. Can it be vibe coded? Yes, it maybe could, just as much as it could be low coded with past tools. But vibe coding is still good for some scenarios, like doing UI. Doing the UI is great. There's very few options to mess things up. Doing a complicated client server application is still not there. So does it change the entire software development process? Not necessarily. We still have the requirement collection. We still have the maintenance. We still have the deployment. We still have the testing. This has not gone anywhere. Maybe writing code is being sped up a little bit. Plus, we need to remember that not all software is SaaS. We still have software which is drivers for a microphone or elevator software or any kind of other system which is not necessarily a classical SaaS. And that one, the LLM did not have enough training examples to actually just vibe code and deploy somewhere with a finger snap. So would AI take our jobs as developers? I don't think so. It might just change the way we work, the tools we use, and as we changed programming languages over time, maybe we'll be using more English than assembler. But if it does, what we will be doing with our time, it's the next trend. Video AI. Now, video AI is used in augmentation and entertainment. Specifically, the reason behind large companies working on it is the future of augmented reality. While companies are still working on it, a lot of the discoveries are used in very different places. For example, I will show you an example in a moment, but the AI is trying to do more personalized experiences. So until now, entertainment was very consuming entertainment. We would sit in front of the TV and consume Disney movies. But from now on, Disney will try to create social spaces where you can actually go online and interact with your favorite Mickey Mouse live. And we see more and more companies investing in this gaming area. For example, Genie 2 from Google and Microsoft also focusing on gaming, but not because they really like playing computer games, but because it's a very easy environment to do research. So if an LLM can learn to play a computer game, it probably can learn to do a lot of other stuff as well. At the same time, in video editing, we see that more and more visual effects are taking place. And a lot of de-aging in the entertainment. Here's an example of AI video effects, and it's very convincing. So we know that studios start to use that more and more. I even know that some TV channels in Austria, like Puls 4, is using it to put costumes on people to be dressed like something, even if the person in the studio is filmed with a normal camera wearing a normal t-shirt. On the screen, they could appear as SpongeBob or Shrek or Teletubbies or a Minion. Now, we've been also promised AI gaming. Here's an example of what's happening in the gaming space. AI can completely generate game scenes, but we've been promised a lot of stuff. We've been promised smarter NPCs and adaptive storytelling, and this did not come yet. And there's a reason for this. What we do see is this procedural generation. So the world is generated as we go. But we somehow don't see these smart characters where you interact with somebody and get a quest or a story that adapts to how you progress in the game. And the reason is the same as the limitations that we have outside of game industry, which is the cost and latency. So it still costs a lot to run those LLMs. It still has a latency, but the bigger problem is the guardrails. How do you make an AI to do only that, what it should do, that it should act like a medieval witch in some game and not explain you how to add pizza and cheese to make it sticky by using glue. At the same time, the big companies are still trying to invest in this idea as a research to take knowledge out of there. And for this to work well, And for people to communicate, we see a trend that did not become a trend, and this is voice AI. The idea of voice AI, I'm afraid I jumped over one. I'm very sorry. Before we go to voice AI, which is a runner-up, we still have the last trend, which is robotics. What is the idea of robotics? The idea of robotics, or in our jargon called embodied intelligence, is that idea that artificial intelligence is not as good until it understands the world, until it knows that stuff falls from top to bottom and how physics works, and if I just drop a cup, it shatters into many pieces. AI wouldn't know how this world really works, and it's not as smart. At the same time, it does not really prevent us from trying to put AI in the real world through robots. And what you see now is the first facility in China to train robots, where humanoid robots, so robots looking like humans with legs and hands, train to work in a varieties of different tasks, a very wide range of applications in real daily life scenarios and workplace scenarios. And this facility hosts more than 100 different robots. It's going to start operating in July 2025. And the idea is to collect a huge amount of sensor data, share it across different robot providers, and teach robots to operate with the real world. And we are quite progressive in that direction. We've also seen a robot training another robot to balance on a ball without falling. And in fact, we also know that robots are already used in some companies. For example, these robots on the pictures are usually being trained in like 45 different types of skills, like grasping, picking stuff, placing and transporting. And we already know that robots from a Chinese company called Walker Ubitech, a robot called Walker S, is already in use in factories of Audi, BMW, and Mercedes-Benz, and also a bunch of Chinese companies like BYD and Foxconn. So a robot is working in the factory, lifting and bringing stuff. Now, under robotics, there is a couple of sub-trends, and the first one is the humanoid robot. Why we go for humanoid? Like, does a robot have to have two hands, two arms? Why it cannot be like Shiva with 20 hands? And the reason for it is because our world is made up for humans. All of the interfaces like door and window and floor and staircase and lift are all meant for a specific form factor. So the world is made for humans, and just adapting the robot to the world would be easier. It will be better capable of interacting with the world. And we also see a lot of sub-trends going. For example, there is a complete new set of computers just for robots. Like NVIDIA is working on this Tor computer, like it's not a video card that sits in the data center, but it's a microchip that sits inside the robot. We have frameworks like the ISAC framework, and we also see models that are only meant for robots. And we not only see models, we also see a different architecture of models, like vision, language, action models. A classical model that we know is transforming text to text. Here it transforms vision to action. And we also see robots that are connected into a hive mind. So Ubitech connected multiple robots into like bees of hives that all connect together. Now there's a lot of crazy stuff going on in this direction as well. There's like text to robot, 3D printer, which can literally print a robot for you based on the description. You tell it, I want a robot that looks like a dog and flies like a bee, and it will try to 3D print it. This is still, of course, a research project. It's hard to imagine a dog flying like a bee, but this area of development is going crazy. And a few things that did not make the cut to be a trend just because of the adoption or the research in it. And the first trend or a runner-up is voice AI. Now, China's AI frenzy with DeepSeek was crazy. Everybody was integrating DeepSeek into everything, into cars, into phones, into even 100 hospitals. And what you see is a air conditioner which is voice controlled. And we have it for a lot of home appliances. So very possible, depending on the tariff situation, at some point our toasters will be also voice controlled. It's not here yet. And I also don't know if it's really a easier user interface. I cannot imagine telling my TV volume up, volume up, volume up, instead of just pressing a button on the remote. But we will see how it emerges. Let's keep an eye on it for 2025. At the same time, some places already already use it. So Continental, Mercedes-Benz, General Motors, they all integrate voice AI into their cars. So you can literally talk to your car. The next runner-up is AI for science. Now, it is hard to call it a trend because it's always been, and it will probably continue to go. For example, last year's Nobel Prize went to a developer of AlphaFold in DeepMind. So it's a algorithm that helps fold proteins and predict how proteins could look like. AI also used to generate new materials, find new chemical compounds, and even being used to do climate simulation and weather prediction. In the healthcare, it's used to do image-guided surgeries where the AI can pinpoint exactly where surgery should happen, on pinpoint tumors. But it is also used to do personalized care, so for everybody find the best care procedure, because now medicine is still based on big numbers. When they research a drug, they're like in 30% of the cases, this drug reduced body fever. So it does not mean that for you specifically it will reduce fever, but it's more likely to reduce fever than not. So personalized care is one of them, and also drug discovery, new antibiotics is something that is being worked on. And from the interesting perspectives, Google offers something called AI co-scientists. So it sits with you, just as we've discussed in the agents. It looks at what you do and tries to help you come up with hypotheses and ways to test them. So an AI agent that acts as a co-scientist that tries to help you do your research. And there are even some other things like the open health stack, so attempts to standardize how healthcare with AI can be done. So this is it for our AI trends. What we've talked about was the agentic AI. Trend number 2 is the very large models as well as very small models and where they go. We talked about inference-time computing, which is models thinking more and more on some tasks. We talked about vibe coding and how it can change the way software currently works. We talked about video AI augmentation and a little bit about gaming. And we talked about the last trend, robotics. We also talked about voice AI, AI for science, and personalized AI as things that we should be looking forward in the future or that are ongoing. And 3 predictions that we will have a AI companion in our life in a way of a wearable like glasses, or even this, what we already have, that on every smartphone, the AI has access to your camera. You can just point your camera around and the AI will see that what you see. We will also see the agentic world growing slowly and surely. We will see trends and tools and AIs communicating with AIs growing. And if your business doesn't have an AI, that's the time to do it. And the prediction that in the future, very likely a lot of our work will be done directly in the AI chat, because tools like the MCP protocol allow just right that, where the AI can communicate with other tools. So if you would like us to help you develop your agents or help you integrate AI into your company, please get in touch with us through the email, phone, or schedule a slot with us through the QR code. It was Alex from OpenResearch. Thank you so much.